Hello, Honors Algebra. Mr. Lawrence here with your flipped lesson. This lesson will be on simplifying radicals. I'm sorry, not on simplifying radicals. That was the last lesson. This will be on using radicals in operations, combining like terms, in other words. For example, if I ask you to add 8 plus 5, you can just say, well, that's 13. Why can you say that? Because they're both constant numbers. If you have 8 of something and 5 more of something, you have 13. But if you ask you to do 8x plus 5y, you should be able to tell me that, well, Mr. Lawrence, you can't combine those. 8x plus 5y is 8x plus 5y. All right. Now remember that, because if I ask you to do the rad of 8 plus the rad of 5, you can't combine those either because they're not like terms. Now, you got to be careful when you do this, because sometimes a rad can be simplified, just like we were doing on last night's homework. And if you take rad 8 and you can break it down into the rad of 2 times 2 times 2, or more simply said, 2 rad 2, and then be plus the rad 5, because rad 5 can't be broken down. Now you can look and say, well, I've got 2 rad 2s here, and I've got 1 rad 5 here, so no, I can't put those together anymore. But what happens if you have a situation like this? If you had rad 8 plus rad 2, you can't put them together as is, because the rads have to match, just like you can't put x's and y's together. But we all know from the previous example that rad 8 is the same as 2 rad 2. Now remember, when you say 2 rad 2, it says I have 2 rad 2s. I have 2 of them. And right here I have 1 more rad 2. How many rad 2s do I have? Well, I have 3 rad 2s. So all I'm doing is counting. That's all I'm doing. I'm counting my rad 2s. All right, let's try a stranger one. Sorry about that. We're having a small technical. Now, when we do these, notice I'm not saying 75 minus 27. This is not 75. Did you hear me, Amber? I said this is not 75. No, it's the rad of 75. I could guesstimate it knowing that the rad of 64 is 8 and the rad of 81 is 9, and that's closer to 81 than it is to 64. It's only 6 away as opposed to 11, so I could guesstimate it at maybe about 8.6 or 8.7, but I'm not going to do that. I'm going to simplify these radicals and then combine the ones that I can. Well, I know that rad 75 is the same as 25 times 3, which is the same as 5 rad 3. How did I get 5? The rad of 25 is 5. Broke it down to 5 times 5 times 3. The pair of 5s left the house on a date. Now, rad 27 is the same as 9 times 3. Well, the rad of 9 is 3. So this would be like minus 3 rad 3. And then I have rad 18 as 9 times 2, which will be 3 rad 2, right? Combining the like terms, notice that I have 5 rad 3s right here, and I have a negative 3 rad 3s right here. But this guy right here is a rad 2. I have 3 rad 2s, but I don't have any more rad 3s, so I can't combine the yellow with the green. So, combining the yellows, I'm going to get 5 rad 3s, take away 3 rad 3s, well, that leaves 2 rad 3s. And then I have plus 3 rad 2. I cannot put anything else together. Have I said that enough times, Zach? I cannot put those together. Why not? Because the rads aren't exactly the same. All right, let's try another. Okay, let's look at this one. Now again, these rads don't appear to be the same, but I'm going to break them down. All right. Now again, if I get the largest perfect square, that is a factor. That makes my math easier. Don't just run to divide by 2 or 4, right? Go for the largest perfect square. 16 is the same as 4 times 4 times 2. I got a pair of 4s. They leave the house. So rad 32 simplifies to rad, 4 rad 2. Rad 50 is an easy one because I know 25 goes in 2 times, and that's the same as 5 rad 2. So rad 50 simplifies all the way down to 5 rad 2. All right, now some of you aren't going to notice 72, so maybe you'll go 9 times 8. And then you can break that down further into 3 times 3 times 2 times 2 times 2. Now you get a lot of dating going on here. You got a pair of 3s that can leave the house on the date, and you also have a pair of 2s. And 3 times 2 is 6, so there's going to be a 6 out front, and a rad 2 is left at home washing his hair because he doesn't have a date. All right, so how many rad 2s do I have here? I have 4. How many rad 2s here? 5. I'm up to 9 rad 2s, but now I have to take away 6 rad 2s, so that means the simplified answer of this is 3 rad 2. See how simple this is? This stuff is cake, guys. Don't make this stuff hard. Okay. I'll give you a couple problems to try on your own, then I think we can wrap this lesson up. Okay, so here are your examples. Go ahead and write those down. Pause the video, and when you're ready to see my solutions, go ahead and unpause them. All right. Now remember, it's advantageous to you to learn these as best you can, because if you can come in and do the formative assessment, you get to start the homework right away. Now, if you can't learn it, well, on your own, then I'm there to help. But it means you'll have a little bit of homework to finish on your own. Okay, so I'm talking enough. I think you need to see my solutions now. I know that 45 breaks down to 9 times 5. I also know that 9 is 3 times 3. I underline my primes. I got a pair of 3s. Rad 45 must be the same as 3 rad 5. 20 breaks down into 4 times 5. 5's prime. This is 2 times 2. They're both prime. Rad 20 must be the same as 2 rad 5. If I simplify further, I have 3 rad 5s, take away 2 rad 5s. I must have 1 rad 5 as my answer. All right, jumping over to example 2. I'm going to do this one more in my head. I know 28 is 4 times 7. 4 is a perfect square. So 28 is going to break down to 2 rad 7. 63. I know that 9 times 7 is 63. 9 is a perfect square. Square root is 3, so I'm going to do minus 3 rad 7. 112, I don't know. I'm not sure what goes in there. I know 4 is going to go in there. How do I know? Because it ends in 12. I don't like to divide by 4, though. I'd rather cut it in half and cut it in half again. So let me see. 112 cut in half would be 56. Cut in half again would be 28. So it's going to be 4 times 28. Okay, looks like I got a perfect square there. Okay, so, I'm going to go ahead and underline this 4. I know that 4 is not prime, but it is a perfect square. So I'm going to break 28 down into 4 times 7. And look, I got another 4. Okay. Wait, I feel like I've made a mistake here. Hold on. No, I'm good. Okay, so I've got 7, which is prime. I have to underline it. So I got a pair of 4s that can leave the house on a date. So rad 112 is going to simplify into 4 rad 7. And look at that. All 3 rads broke down into rad 7s. There's positive 2, a negative 3, and a positive 4. Well, I know that 2 and 4 is 6, minus 3 is 3, so my answer must be 3 rad 7. Okay? Notice I didn't touch a calculator for any of this. You won't be allowed to either. Your geometry teachers are going to expect you to know how to break down rads. It's a big part of math from geometry, algebra 2, and so on. Okay, this is Mr. Lawrence signing off. Have a good night, everybody.